Good morning and welcome back, quantitative analysis students. For our last lecture of the term, this is chapter 6.1, arithmetic sequences and simple interest. At this point, everybody knows where they are in the class grade-wise. We also are all aware of what's coming in the future. We're about to wrap up the term, and there is a final project that's due, and that's going to happen next week. Also, there will be an exam on the material we've covered thus far for the third part. Remember, it's not cumulative, it's just the last 5 sections or 6 sections since our last exam. Exam number 3 will be held on Monday. All right, today we're going to talk about simple interest in arithmetic sequences. First, I want you to remember a very basic concept that is really crucial for your success in business, and that has to do with something called return on investment. The return on the investment is a small percentage, and it represents how much you've gained or how much you've made out of an investment. A perfect example is if you've invested $1,000 and you came back with $1,200, that means that, you made $200. 200 over 1,000 is 20%. So your return on investment in that situation is 20%, meaning you've increased 20% of what it was. Or you could also say it this way: the new amount is 120% of the last amount. And we need to be fluent and comfortable with all of the semantics of percents that way, so that when you talk to your clients, you know how to communicate correctly, especially when it comes to percentages. It's easy to confuse percents when it comes to increasing and decreasing and things like that. And we'll explore that a little bit today. We're going to keep our primary focus on the idea that the interest is the principal times the rate times the time. And we're also going to keep our primary focus on the idea that the future amount is going to be the original amount plus that interest. And that shows up in a variety of ways in formulas and in different situations with our applications examples and such. But the most important thing up front is this general basic concept of return on investment. The way you find a return on investment is you take all of the gains that you've made and then you divide it by the cost of the investment. Now, the gains could come in all different kinds. Gains could be interest, gains could be dividends, gains could be an increase in stock shares. It could be an increase in stock price. Anytime that you hear that there was money that was brought in, what the reasoning doesn't matter why it came in. Did it come in because of an interest or because of a stock or because of a dividend? It doesn't matter why it came in. But if you take all of the things that came in as a result of you starting an investment and add them up, that's your numerator. And those are called gains, okay? And then also we have the cost of investment. So for example, let's say that you open up a mutual fund and you put $1,000 in there. There might have been a $10 fee to get a checkbook or to get a coupon book, or there might have been a $5 bank fee for a new register or some kind of, whatever that is. Make sure you add those, because the cost of the investment is the amount of money you are investing, but then any associated fees go along with that. And you will see situations like that in WebAssign and in your examples in the textbook when you do your practice, where they are giving you information and it's on you to get it, that the cost of the investment is all the money you invest plus the fees it costs to invest, and that the gains are any and all new money coming in as a result of you making that investment. Okay, so return on investment comes up over and over again in the chapter. Now let's focus our attention on the basic formula for interest, which is interest equals principal times rate times time. As a reminder, principal is the amount that you've invested. The rate is usually given as a percent. So in order to include it in this formula, you have to convert it into a decimal. And that's something that's an old skill set that we have to be familiar with. If you struggle with that, that's okay. We'll talk about that a little bit today, moving the decimal point 2 places and all of that stuff. And then last but not least, the time. The time is in years, and that means that for certain specific lengths of an investment, you might have odd fractions. For example, if I tell you it's 13 weeks, well, you're going to think 13 divided by 52 because there's 52 weeks in a year. If I tell you it's 7 months, then you have to think of the time as 7 over 12 because there are 12 months in a year. If I tell you it's for 3/4 of the year, of course, you're going to use the fraction 3/4. And if I tell you it's 2.5 years, you have to use 2.5. So things like that, when it comes to the time, just kind of remember to use your old basic ideas of how many weeks are in a year, how many months are in a year, and all that kind of stuff. And just think of a fractional part of a year in that way. All right. So we have all of the important variables explained very clearly here for you. And it says, note that the measurements for R and T must agree. In other words, since R is the annual interest rate, annual meaning yearly, the time is in years, which also means yearly. And there are examples of situations where um, they give you a different kind of interest rate or a different kind of time. They'll give it to you in decades, or they'll give it to you in days, and you have to make sure you convert it to years. Likewise, there's ways to convert interest rates as well. If it's annual, you can use exponents to change it into biannual or monthly and things like that, and we'll talk about that today also. All right. All right, let's just jump in with a very basic example. This is an application where you are just substituting in values according to a story. Let's look at part A. It says if 8,000 is invested for 2 years with an annual interest rate of 9%, how much interest will be invested at the end of a 2-year period? So they're actually asking you what is the interest, and if they want to know what the interest is, then this is the most basic question there is. You're going to just use the interest formula. First, we're going to focus on how 8,000 is the principal. And then we're going to focus on how 2 years is the time. And then we're going to think about how 9% is the rate. But 9% is in percent format. So we're going to say the rate is 90%, which is the same as 0.9. I'm sorry, 0.09. Oops, I fell right into my trap there. It's not 90%, it's 9%. Oh, sorry, guys. I hope you're following what I'm saying. I was trying to see if you're paying attention. I'm just kidding. That was a mistake there. But of course, if it's 9%, it's 0.09. I want to talk to you for a minute about how easy it is to convert back and forth with percents. I have a basic idea here that I want to bring across to you before we do this question. I'll do it in red over here. We all know about 50%. We know that's 1/2. And we know that's 0.50. If you can remember that as a benchmark, you'll always know which way to move the decimal point. Like, in other words, if it's 9%, how do I change 9% into a decimal? Well, if it was 50%, I would take the decimal point that was originally right here and move it 2 spaces to the left, which is right here, which is why I have it, as you can see right there, as 0.50%, as 0.50 there. So in other words, you can think about 50% and 0.5 as a model to remember which way to move the decimal point. And I encourage my students to do that if they're struggling with changing percents to decimals. All right. Anyway, so that's a great little idea to think about. Now let's think about the solution here. I'm looking right now at this piece here. I have a formula, I equals PRT. The P is 8,000, the R is 2, and the T, as we have established, is 0.09. So we plug them all in here, and now, as you see, here's our answer. Remember what the question was. The question was, how much interest will be received? You have to make sure you're answering the question, because if the question said something like, what would the amount be at the end of the term, you might want to add it to 8,000 and so on. So just make sure you're answering the question very carefully, okay? Let's look at part B now. It says, if 4,000 is borrowed for 39 weeks, at an annual interest rate of 15%, how much interest is due at the end of 39 weeks? Okay, well, once again, we have a principal, and here's our principal, right? And then we have a very interesting time here. We have 39 weeks. So 39 weeks now, remember what we talked about. It has to agree. It has to be in, it has to agree. And if you notice, the interest rate given is an annual interest rate. So we have to make 39 weeks a different kind of time that's in terms of years. How many weeks are in a year? The answer is 52. So the time, this time, is actually not 39, but 39 over 52. Now, I wouldn't go and get a calculator and figure that out. I would just leave it as the ugly fraction it is, and then go on later on with your calculator and plug in just that fraction the way you see it and see what comes through. Last but not least, we're also given a rate. Our rate this time is 15%. So for this rate, we're going to say the rate, which is 15%, should be converted into a decimal, which should be 0.115. I'm sorry, 0.15, like so. All right, so now with that in mind, I think you could see to they're asking you how much interest is due at the end of the 39 weeks. Well, we're going to use this formula again. And like we had mentioned, we're going to say t is going to be this value, which is 0.75 years. And therefore, if we plug the numbers in, I equals PRT, you get 450 as your solution. All right, guys, so I hope you're able to follow that example. For the most part, example one is just the most direct kind of question there is find the interest if it's I equals PRT. I want you to also use your study skills to try to remember the wording in these questions to keep that as an indicator of how you should figure out the answer. For example, one way to say it is how much interest will be received at the end of the period. Another way to say it is how much interest is due at the end of the period. The wording is due or will be received. It sounds like they're conflicting, but they mean the same idea basically. And I want you to keep that in mind when you're doing these questions to know that this is a kind of question that's just asking for the interest for I. All right. All right, that's example one. Now let's talk about this idea of future value versus present value. So in these different stories, you'll notice that we did have a certain amount of interest that was earned. We would invest 4,000, we would figure out how much it would cost, how much interest there would be, and then that would be earned or due or whatever you want to say. But it's the amount that is the result of using a specific principal with a specific rate at a specific length of time. In that story, we have three different important quantities. We have the original value, which is called the present value. And then we have the interest that is being added on to it, which is new money that comes in. And then that is something we're going to call the future value. In other words, I can assume making this present amount an investment with all of the different parameters of how it's being invested, the time and the rate, that there will be a future value that is based on my original value plus whatever the gains are. All right. So in a very basic model, we have S equals P plus I, which means future value is present value plus interest is what they're trying to say there. Okay. So we're going to use this formula and notice that I also has its own little formula. I is PRT. So I can rewrite this to be S equals P plus PRT, and that's another version of the future value formula where the variable I is replaced with the formula that represents I, which is PRT, and you'll see that in a little bit too. So let's look at example two, and you'll see in example two that we are actually going to include that idea. If the video of me talking is anywhere in the way, you could just click and drag it out of the way. Right now it's kind of in the way of one of the formulas, so I moved it. Example two, let's jump right in with part A. This is loans and investments. If 2,000 is borrowed for a half a year at a simple interest rate of 12% per year, well, what amount must be repaid at the end of the half year? So it's the same idea as you making an investment and earning interest is the same idea as you borrowing money from the bank, as if the bank is investing in you and then you have to pay them interest back so they are earning interest for their investment in you. It's the same story. It's again, a present amount plus an interest becomes a future amount, okay? So we're going to start by thinking about all the different quantities we see in here. And I see in here 2,000, that's the principal. And then I see a half a year, okay? So that is our time. And it'll be 1/2 this time, or 0.5. And then we have a simple interest rate of 12%, which tells you that the rate is 12%, oops, which is the same as 0.12 as a decimal. And we're asking you what amount must be repaid at the end of the year. So when you figure out what the interest is that the bank earned on investing in you, you have to give them that, but you also have to give them the loan money back too. So if you borrow 2,000, you have to give them back 2,000, and you have to give them also on top of it the interest that was earned based on these different parameters, a half a year and a 12% interest rate. So what you could do is first figure out the interest. Which you see right here, here's the calculation of figuring out the interest. It's PRT, and we just put them all in together, and you find out that the interest that you'll have to pay to make this to take this loan out from the bank is $120. So what I need to do is think about how 120 is the interest and the present value is 2,000. So what would the future value be? And as you can see, I'm using this formula, S equals P plus I. P is 2,000, I is 120. So I guess S is 2120, meaning the future value is the original amount 2,000 plus the interest 120, which is 2120. Look at part B. An investor wants to have 20,000 in 9 months. Okay, so listen to how now we're kind of giving you odd numbers that are kind of, we're asking you for a number we used to give you. You know, that's what's happening here. So if the investor wants to have 20,000 in 9 months, if the best available simple rate is 6.05% a year, how much must be invested now to yield the amount? So, okay, what is 20,000 then? 20,000 is what the person wants at the end of the term. In other words, 20,000 is the future value. And then we're telling you that it's going to be a 9-month investment. If it's going to be a 9-month investment, then I guess the time is going to be 9 months out of the 12 that are in a year. So we have a strange looking fraction for the time. And also we have an interest rate to deal with here. The interest rate is 6.05. So the interest rate then is going to be that percentage, or as a decimal, what would that be? Be careful about your decimal movement. We do have to move the decimal point 2 spots to the left, which means we have to include a new 0 in the 10th spot to show our rate. And now we're asking you, how much must be invested now? How much must be invested now? To find out how much must be invested now, that means we're saying, what is P, the present value? Okay, so as you can see, I've carefully analyzed part B here. I've identified what each of the quantities are in the word problem, and I'm ready to use formulas that I was given before. Now, last time I calculated the interest separately. This time I'm going to include the interest in the formula, and I'd like to focus your attention, guys, right here. I'll make it red on this formula right here. Trying to make it red, come on. This formula right here is the same as this formula right here, look, except the I has been switched to be PRT. And the reason why is because I want to find out all at once what that interest would be and include it in the whole scheme of things with the future and present value. So follow the arithmetic, you'll see what's happened here. We know we're going to use this formula, and we also know that we can replace the I with the PRT like we had said. So we're going to solve for P, and we're going to use 9/12. So here's the formula. It's S equals P plus PRT from over here. And we plug everything in except for the P. And then as you can see there, we wind up with, there's a 1 there. If you can't see it, I'm going to insert it right there. So I've put that 1 in front of that P. Let me put it in a little bit better. All right, so it's 1 plus that quantity, and you can see 0.0605 times 9/12 is that very long, strange decimal. I'm going to encourage you to try to keep all your decimal places as long as you can. See, it's 045375. Keep all those digits, you know. And if it's 1P plus that P, then you add 1 plus that decimal, and you get the new coefficient 1.04537. And then you just divide both sides by that funny coefficient. And the figure is this. Now, look back and ask, does that make sense? If I invest 20,000, if I want to get $20,000 and I'm earning interest, shouldn't the dollar amount be less than 20,000? Yes, it should. And it makes sense that 19,000 is the answer. Now, 6.05 is a really good rate. And that's a very large principal to be laying down. So yes, you could earn $850 in just 9 months if you have that much money, but you have to find a bank that will be able to honor that and that will give you a rate like that. So there are great ways to make money in that regard. Okay. All right. Carrying on, let's look at example 3, which is about evaluating an investment. Mary Spalding bought WinGen Electric stock for this much money. After 6 months, the value of her shares had risen by this much, and dividends totaling this much had been paid. Find the return on investment. Now you recall that the return on investment is going to be this little formula where you think about all the money that has come in and you divide it by the total amount that you've invested. How much has Mary invested? We're told that she has invested $61.25. We also look closely and we don't see any kind of associated fees or anything. This is the gains on investment. Next, after 6 months, the value of her shares had risen by this much, and dividends totaling this much has been paid. Those two figures you're looking at there are representations of gains, okay? If you ever hear the wording shares had risen, geez, I don't know how many times I have to press it. There we go, okay. Shares had risen by this much, and we also have dividends totaling this much had been paid. Listen closely to those words. Shares had risen by a certain amount of money. We don't have to think about how many shares she has or how much each share has risen. We're just told in general, because of shares, there's a gain of 138. So you don't have to think too deeply about should I divide that by how many gain or any of those things go through my mind when I see it, but it's just that's one of the gains, 138. Here's another gain, 144.14. That is a dividend that was come, or there were many dividends that added up to that or whatever. And these two numbers represent the gains. So now if you want to find the return on investment, it's just a matter of using the formula and putting the sum of those two gains on the top and the actual cost of the investment on the bottom, divide. Remember, a return on investment is usually given as a percent. So whatever you get, make sure you convert it back to a percent like you see there. All right, now, for part B, it says find the simple interest rate she earned on this investment if she sold the stock at the end of the 6 months. That's a pretty coded kind of question. And it might not be clear that what they're asking you to do is figure out what the rate would have been given all of this information, considering that the gains were acting as if they were the interest earned. So think of it this way. I put the money in, and when I'm done with putting 61.25 in, 61.25 plus that amount, that numerator is what I got back. There is an increase from 61.25 to whatever the new amount is some $300 more is what the increase is. I can look at that amount that it's actually $282.14, and we have that actually here in the solution. That increase from the original amount is the return on the is the gains on the investment. If I view that amount as if it was interest earned, then I would instead use that amount, 282.14, as the capital letter I. And then consider that the rate was given as a, the rate is the thing we're looking for that we don't know. The time is given, it's 6 months. And we can plug everything else in there, including the initial amount, meaning the principal, as 61.25. So what we're going to do for a question like this is actually, once again, go back and use that formula that we've used before, which looks like this. I equals P plus PRT. So for this one, we just need to recognize that the actual interest is the money. So we're just going to use I equals PRT. And now I'd like to focus your attention right here, where I'm using I equals PRT right here. There's the interest, which is the sum of the dividends and the share increase. And we're saying it equals the principal times the rate times the time, as if the principal is the original cost of the investment, which is 61.25. The rate is a figure I don't know that I'm trying to figure out. And the time is given as 6 months. So you see in there, I used 0.5 for the time. I've used 6125 as the principal P. And I'm using the interest to be the actual gains on the investment, which is 282.14. If I solve the equation with all the algebra skills, I wind up with this figure here, 0.092. And you should know as a percent, that's supposed to be changed to 9.2%. So what does it mean? If it was equivalent to an annual simple interest rate, it would be 9.2%. But that's not the way this was calculated. Instead, this was calculated as here's an investment, here are some dividends, and here's an increase in your stock shares. It's the same idea as here's your amount and here's the interest you earned. And what they're trying to say is if it was interest, what would the interest rate have been to make it the same amount? And it would be 9.2%. The reason why they do things like this is because 9.2% is kind of a high interest rate when it comes to returns. You might not get something that big. You probably would get something, though, in terms of dividends and stock increase that might be comparable to it. And that's the point of it. All right. Now, for example 4, which has to do with the duration of an investment. Last time, we were trying to figure out what is the rate that would make this all perfect. Now, what I'm going to do is ask you the question, what is the length of time of our investment that would make everything just right for what we want? Here, we're talking about $1,000 that's going to be invested at a certain specific rate of 5.8%. And how long should I leave that in that investment until it becomes 1,100? Because I want to see it become 1,100. Again, what's happening this time is your variable is going to be something unusual time. So what will we do? Of course, we're going to think about the relationship between the future and the present values. And we're going to use P as our present value. We'll use S as our future value, which we're hoping for 1,100. We're telling you what the rate is. The rate is 5.8%, so R equals 0.058. And our goal at this point is to figure out what would T be. So as you can see, we use a little basic algebra, plug everything in the way we're supposed to, and then do some manipulate the equation, divide both sides by 58, and then you get your answer, 1.72 years. Remember that it is in terms of years. All right, and so for example 4, we have a great case of what is it like when the time is what you're looking for. All right, now in both example 3b and 4, it's not really clear up front which formula to use. So I would kind of just consider both and think about which one would get me the answer quicker. And this one, S equals P plus PRT, is really crucial to use. And the last one, you could have used that too, but it was easier to use just I equals PRT. All right. And again, we're only really using a couple of formulas, the return on the investment, and then the future value, and then the simple interest rate formula. All right. Now, I know that you know what it's like when you compound interest, how month after month, the amount increases and increases again. And then when it increases to its new increased amount, you take that amount and find a percent of that new amount and add it on. And then it's a new amount again, and then you find a percent of that new amount again. That rapid increasing that's happening with an investment, it's associated with something called continuous. If it's really happening quickly to the point that it's per second or even faster, but we're talking about it in terms of simple interest, where we have basic increments each time we assess again what the interest should be. In this particular situation, we're talking about a monthly assessment. Let's look at the data over here with me. I'm going to zoom in on it, and I want you to think about these numbers with me right now for a minute so that we can get a little bit of a grasp of what they're talking about. Let's look at the monthly future values of a $2,000 investment that earns a 1% simple interest for each of the 5 months. So in the beginning of the month, what happens is, and I'm focusing now on this part, at the beginning of month 1, we have $2,000 and we take 1% of $2,000 and it's 20 bucks. So the future value of the investment at the end of 1 month is the original amount, $2,000 plus $20, which is $2,020. Now, here comes month 2. For month 2, you'll see that we're taking $20, you're taking 1% of the original amount again and adding it on again. So it's gone up by $40. This is the idea that it's not compounded every month, but instead it's using the original amount again every month. And you'll see that the amount that increases each month is the same. It's $20 each time. Now, if you have a case like that, really what's happening is you could just count the number of months, 5 months, and then think about 5 times this 20 and adding it on to 2,000, and see how you get that there as well. You get 2,100. This is something we call an arithmetic series in mathematics. And now I'm going to switch your attention from finance mathematics to more abstract and conceptual mathematics, where we have the idea of something called a sequence or a series. A sequence or a series works like this. We give you an original amount, And we keep on adding or subtracting the same amount to it each time. So a sequence is a function whose domain is the set of positive integers is called the sequence function. The set of function outputs of a sequence function look like this, and it forms an ordered list called a sequence. The outputs, A1 through A's, all the way, all those A's are called terms of the sequence. The most basic example of a sequence function is your times tables. When you go 3, 6, 9, 12, 15, and you count aloud the times tables, you're basically reciting aloud a sequence, an arithmetic sequence. And the reason why is because you're adding the same number each time. The initial value in that kind of a sequence is 3. The common difference is 3 because you're adding 3 each time. And the sequence carries on forever, like any sequence would. That's a very basic one, but as you could see, they can get more complicated. They can be in the thousands. Here we're in quantitative analysis, so they could even become the millions. You know how that works. Let's take a look at an example of one. For example, 5, let's talk about terms of a sequence. And I chose to share with you example 5 here before we go in and do the rest of them so that you can see the basic concept of what a sequence is and how it works. Write the first 4 terms of the sequence whose nth term is a sub n equals, and we have a strange looking formula. I'd like to show you how to do this on paper, and then we'll come back and review what it looks like there. First, let me jot down the actual formula, and then we can go through how you would answer a question like this. The formula is, and we say out loud, a sub n is equal to -1 to the n all over 2n. Okay. Okay, friends, I'm going to ask you to make sure that your view is toggled to speaker view so you can see very clearly what I'm writing here. And I'm going to start now by thinking about how a sub n is very comparable to the idea of f of x. If it looked like this, once you know how to do it, it's the same exact thing. It's like f of x. So to figure out what the terms are, and if they say, please find the first 4 terms, what they're saying is, can you please find a sub 1, a sub 2, a sub 3, and a sub 4? Please find the first 4 terms. How do you do that? Well, you carefully plug the n value, which is 1, into the formula, and you get -1/2 for this one. For a 2, it would be -1 squared over 2 times 2, which is positive 1/4, right? And you'd carry on and keep on going with it by plugging them in. So please remember, my friends, if you are asked to list the first 4 terms, you're basically doing 4 questions all at once. Also, a brief mention while we're in this conversation, whenever you take -1 and raise it to an odd power, you can expect your solution to be -1. If you raise it to an even power, you can expect it to be +1, right? That's a little math logic for you, okay? So these are the solutions we were expecting for this question. Oh wait, 2 times 4 is 8, not 16. Look at what I did there. I always do the hard stuff right and then mess up the easy stuff. Anyway, carrying on. And you could look very closely there and you'll see your solutions are all there. Please don't let this confuse you. This has to do with the way that, screenshots work. It's not really very clear, but like right here, I just want to mention for you guys while we're talking here. Right here, this is actually an equal sign right here. This is an equal sign, but it looks like a negative. See, this is what they mean equals -1/6. This is equals -1/2. Here, this is an equal sign. So, that's because of the way that it just happens to work out that way. Don't let that confuse you, but I just want to make sure that's clear to you. And your final solution should look kind of like this. Could you please write the first 4 terms? Sure, here they are. These are the first 4 terms. And put them in a nice list with commas. And notice they're in order. The first term is this one here. The second term is this one, then this, then this. They're not in order from lowest to greatest. They're in order in terms of the first term, the second term, the third term, and the fourth term. So you're supposed to answer them in a list that way. so that they are in order of the terms that they're supposed to be. Okay? All right, so that's your first basic concept associated with the terms of a sequence. Let's carry on. These three formulas are really important for you to succeed when it comes to figuring out different parts of a sequence. First, let's talk about what is an arithmetic sequence. An arithmetic sequence can be viewed, and I'm going to zoom in a little bit because it's kind of small to see. An arithmetic sequence can be viewed in this way. It is ultimately every term that you have, meaning the nth term, is always the last term in the sequence, which is a sub n minus 1, meaning the last one. Like, for example, if I'm talking about term number A37, right? A37, the last term is A36, which is 37 minus 1. So for any term that I'm thinking about, if I take the last term just behind it, which is called the A sub n minus 1, and add the difference to it, a common difference, and then I'll get the next term. So that's the point of an arithmetic sequence, is you have one number and then you have a measurement that is the common difference that you keep adding to the number to get the next term and the next term and the next term, right? This is the basic general idea of it. It's not a formula that you would really use particularly in this chapter. It's just the idea that every term you're looking at is the last term plus that common difference. All right. Now let's think about this, the nth term of an arithmetic sequence. If you're in a position such that you do know what the difference is, and you do know what the first term is, and you also know which term you're looking for, you should be able to get the answer using this formula. Like, for example, here's a sequence, and I give you a sequence. Looking at the sequence, you can immediately looking at a sequence, you can identify what the first term is simply the first number in there. You also know what the difference is if you think about what the jump is from one number to the next. If you know that, and you know that it's an arithmetic sequence, you can use this formula to find any term. Say I want to find the 115th term. I'll put 115 in there for n, and it will give me the solution of whatever that 115th term is there. So we're going to use this formula a lot when we're trying to figure out a specific term. Can you tell me the 41st term? You got to use this formula because it's called an nth term in that case. N is the 41 or the 41st term that way. Right? And one more important formula right here. This has to do with the sum of the terms. So let's say I wanted you to add up the first 15 terms of the sequence. You could go through and list all 15 of the first terms and then add them up. You could do that. But what if I say, can you give me the sum of the first 85 terms? Well, that's a little bit much to write 85 terms out. So instead what you do is use this formula. Now look at how this formula works. This notation right here, S sub n, means the sum of the first n terms. For example, can you tell me the sum of the first 33 terms? Then I'm finding S sub 33, meaning that I need the first term itself, and I need the 33rd term itself. I'm going to add them up, and then I put 33 right here and divide by 2 and get my formula. Now, there are reasons why these three formulas work. We could go through a long and involved proof about why they work. And by the way, that's very interesting. If you took Calc 2 or Calc 3 when they study sequences, I think Calc 3 is where they study sequences in depth. But there are proofs behind why these are what they are. And you can show using general concepts why these formulas wind up being what they are. But for our scope in quantitative analysis, you don't need to focus on that as much as you need to recognize that these are the formulas and these are how, and we're going to use these formulas to answer questions about banking and investments. Okay. Before we do it with investments, though, let's do it with some basic numbers and think about it in an algebraic way so we can get the feel of how arithmetic sequences work and how to find the nth term of one of those sequences. And last but not least, how to find the sum of an arithmetic sequence from one term to another. In example 6, we're asking you first to please write the next 3 terms of each of the following arithmetic sequences. I'd like to write them down and then talk about them with you, how you would figure them out. Let me just jot them down. This is example 6. And we're going to do first 1, 3, 5. Then we're going to do 9, 6, 3. And then we're going to do 1/2, 5/6, 7/6. And you're asked to write the next 3 terms of each. So make sure that you answer their question that they're actually asking you about. Okay, so here are the 3 questions we're asked to do. You want to come up with the next 3 terms, okay? For some of them, it's going to be really easy. For example, for 135, I think you could see what it's supposed to be, right? 135, what comes next? 7, 9, 11. The common difference here is simply 2. The first term is 1, all right? How many terms do I have here? Right now I'm looking at 6 terms, so I'm going to say n equals 6 this time because there are 6 terms. Look at part B. What is the pattern? 9, 6, 3. What's happening each time? I'm subtracting 3 each time, right? So what I'll do is I'll say the difference is minus 3. So I'll do that again. Now, what is 3 minus 3? 0. What is 0 minus 3? Minus 3. What is minus 3 minus 3? Minus 6. In this case, a sub 1 is 9. And there are, again, 6 terms total now. Okay? Let's look at this one. Notice we have fractions, which might be a little bit intimidating. However, I do have common 6s here. Is there any way I could figure out a way to get this to look like a 6? This question, something like this, you might recall. When you were adding fractions back in elementary school, you would divide this way, and then you would multiply this way. So you divide and you get 3. 3 times 1 is 3. And of course, if you reduce this in 3/6, the same as 1/2. Let's rewrite this now. 3/6, 5/6, 7/6. It's like 3 apples, 5 apples, 7 apples. Same idea. So what comes next? Okay, 9 apples, 11 apples, 13 apples. And by the way, this is not very nice. So we're going to be smart and change that into 3/2. The same way this was changed into 1/2. And these are the solutions we're actually looking for. This number, and this number. What is the common difference this time? You'll notice the change from here to here is 2/6, which is also known as 1/3. Last, what is the actual first term here? A sub 1 for this is 1/2. And how many terms are there? 6 ultimately. Right? Now, example 6 is a great way to explore and get your feet wet with the idea of, now they didn't ask you what is the common difference. They didn't ask you what is a sub 1 the first term. They didn't, I kept that in there just to kind of help you see how these sequences work. But when you're looking at them, you should keep that in mind. And there may be a moment where you have to know what that difference is looking at it. So we'll see that in a minute. All right, now for example 6, it does tell you what the common differences are. And it tells you what the next 3 terms are there. And I just want to make sure that everybody is comfortable with that material. And, if you don't see it, then we can talk about it some more. Just let me know. I'll explain it a little bit more for you. Let's focus our attention now, my friends, at example 7. In example 7, it says, find the 11th term of an arithmetic sequence with first term 3 and common difference 2. So this time you want the 11th term of an arithmetic sequence. So which formula will you use? It's going to be this formula right here, is it not? So let's think about that. It would be a sub n, which is, in this case, n is 11, right? And we're telling you it's an arithmetic sequence, which tells you that you certainly can use this formula because this formula is only for arithmetic sequences. And then we're telling you the first term is 3. That means a sub 1 equals 3. Right? If a sub 1 is 3, good to know. And the common difference is -2. Okay, d equals -2. So can we use our formula here now? Of course we can. Here it is, substituted in. A sub 11 will be equal to 3, which is our a sub 1 right here, plus, and I'm not going to highlight each thing, it's going to make it harder to see. I'll just put arrows. So I have 3, which is our a sub 1 that we've established. And then we have n minus 1, n is 11 this time, right? And then we have our common difference, which is -2. We plug it all in and figure it all out, and here we go. We get -17. So what is the 11th term of this sequence? The answer is -17. If you want, you could count it out. Let's think about that. If it was 3 and the common difference was 2, it would be 3 would be the first one, and then 1, and then -1, and so on. Keep counting. You're going to get down to -17. All right. For part B, it says if the first term of an arithmetic sequence is 4. Okay, so now we're trying to tell you that the first term of the arithmetic sequence is 4. So we're telling you that a sub 1 is 4. Okay, so if the first term is 4, great. And then the ninth term is 20. Okay, hold on a minute. The ninth term is 20. Let me write that down. A little 9 in here. Okay, now find the 75th term. Wow, it's pretty heavy, huh? Find the 75th term. Well, if I'm finding the 75th term, what is n? N equals 75. And that's another important thing. All right, so here's my information. I'm trying to figure out the 75th term. That means I'm trying to find the nth term, right? Yeah. I'm going to use this formula once again. All right, so like we have established, a sub 1 equals 4, a sub n equals 20, and n equals 9. If we use this formula right here, we're going to figure out what the nth term is. Oh, what's happening here is first we're trying to figure out what the actual difference is. And the reason why we're trying to figure out the difference is we kind of don't know the difference. We've got to figure that out first. So we're using that original formula where we know where we know that we're using a sub n is 20. 4 plus 9 minus 1 times d, as you see here. And we're plugging those all in according to the formula that we see up there. And or is it this formula here? It's this formula here we're using, yes. And it will give us what the difference is. The difference this time is 2 because of all that arithmetic. So the first step in finding example B, 7b, is figuring out what the difference is. We have found the difference to be 2. Now, if you want to find the nth term, now you can use 2 as your difference and go back and use that same formula once again to get what the difference is. A sub 75, the n is 75 in this case. All right, and then we have plugging in the values. The first term is 4, n is 75, so it's 75 minus 1. And our difference, we've already established, is 2. So to figure out the answer, we would plug it into there and get 152 as our answer. Okay. And one more, let's talk about this one. And this one is a little bit of a project. There's a lot of stuff in it, and this is our last example for today. It's about the sums of arithmetic sequences. Find the sum of the first 10 terms of an arithmetic sequence whose first term is 2 and whose common difference is 4. That's one of the most straightforward, easy questions there is because you know you're trying to find the sum and you have all the things that you need for a sum. Here's what you need for a sum. You need n, you need the first term, and you need the last term. Before you do that, though, we don't have the last term, so we're going to need to figure out what that last term is using the nth term. So how can I figure out that last term? Well, if it's the 10th term being the last term, look at what we do. We say, let's figure out what S sub 10 is first. And S sub 10, we can, I'm sorry, not S sub 10, A sub 10. Let's find out what A sub 10 is first. The 10th term can be found using the original formula here by putting in the first number, 2, and then adding 10, which is our value of n, minus 1, and then multiplying by our difference of 4, which we are given there. All right. Now, if we figure that out, we get 38. And what that means is that the 10th term actually is 38. Let's highlight that. That's kind of important. So if 38 is a sub 10, now I could figure out what the sum of the first term of the first 10 terms is by using 38 as the a sub 10, using 2 as the a sub 1, and then of course using n as 10. Do a little calculations and you get 200. Your solution will be 200 for that question. Yeah. Okay. And then the last one, it says, the first 91 terms of find the sum of the first 91 terms of this arithmetic sequence. That's going to require you figuring out what the difference is and also finding out what the 91st term is by using the nth term formula. The only thing here is it's a little bit complicated because of fractions. So let's first focus our attention on trying to figure out what the common difference is. The common difference is going to be 1/3. And the reason why is because if I take any of these two consecutive fractions and subtract them, I'm going to get 1/3 as a result, meaning 1/4 plus 1/3 gives 7/12. 7/12 plus 1/3 will give the 11/12, and so on. Next, I got to figure out a sub 91. So to find the nth term, a sub 91, I'm going to use this formula again, with the n being 91, and with the first term being the fraction they gave, which is 1/4, and with the difference being the difference that they gave, or that we found, which is 1/3. As you can see, it's a little bit complicated. This is the arithmetic you're supposed to do to get that answer. After you work really hard to get it, you get 30 1/4, or 121/4. That right there, that number, my friends, is the 91st term. So now that you have the 91st term right there, you also have the first term, which is 1/4. You can figure out, and you have the number of terms, which is 91. You can figure out the sum of the first 91 terms now using this formula. This is borrowing right from here. So we plug in n for 91. We're plugging in 1/4 for a sub 1, and we're plugging in that uncomfortable fraction 121/4 as the 91st term, a sub 91. Calculate, you could do it with a calculator or with a pencil, and you get a very uncomfortable number. Here's your number right here, guys. Or you could write it as an improper fraction right there. I would recommend that you keep it in fraction form when you're putting your answers into Desmos. If you change it to decimals, it might round it, and then you might get it marked wrong when you could have got it right if you just put the fraction in, which was a waste of your time to divide it then in the first place. Also, please note, WebAssign, excuse me, WebAssign does accept unreduced fractions, so you should use that. All right, well, let's see. I guess we made it. That's it. And now that you've learned all about simple interest and arithmetic sequences, you're in a position to go now into WebAssign and do WebAssign practice number 11, which has been made available now and is due on the day of your exam, which is on Monday of next week. I'm going to stop our share now, and then I'm going to open up the floor to questions. Again, it's been a pleasure studying with you, and thank you for listening to all of my ideas and all my examples. I hope it was helpful for you.